Good evening, everybody. At the outset, I would like to thank Dr. Sendil for organizing this webinar. And it's a very important topic for most of us, and especially those of us who are running individual practices on our own, and wherein we have to do most of the things ourselves and monitor many of the things ourselves. So I'll be speaking on understanding the steam sterilization. Before I start with my presentation, let me begin with a small quiz here. So how many of you have an autoclave in your hospital or a clinic, whether it is a horizontal or a vertical autoclave? Well, many of you will answer this question. There's no marks for answering this question. My question is it N type, S type, or B type, or a class B type? Next is, how did you decide to buy your autoclave? You followed a senior ophthalmologist, phone a friend or a friend's recommendation, or was it a company marketing? Or you knew exactly what you wanted and then you bought it. If your answer is 4, then you can mark it as a mark for yourself. Then which is this steam here in the photograph that you're seeing? Then an easy question for you. What are the parameters for doing phaco in a hard cataract or a soft cataract? Many of you will get it correct. But the question here is, what liquid or water do you use to clean your phaco handpiece? Which syringe do you use to clean your phaco handpiece? And what is the minimum recommended amount of water to be used for flushing? And how much of air has to be flushed after cleaning with water? The next question is, in which part of your sterilizer would you like to put your phaco probe? Would you like to put it in the upper rack, middle part, lower part, or it does not matter at all? Well, our approach to sterilization is something like trying to have it as a fast food, eat quick, finish it fast. And then we expect that we learn about A to Z of instrument sterilization. Well, it is absolutely not possible to cover this topic within half an hour or so, because one protocol will not fit another practice. We need to customize it for your practice. So I'll be just speaking to you about the ABC of steam sterilization, that is all basic concepts. So what you need to understand is, if you are to customize anything, you need to understand the settings, and you also need to understand the process. Only when you understand these things, then we can reach the desired target. The aim of this talk is not to give you ready-made answers or knowledge, but to raise the correct questions so that we understand the basis of steam sterilization and develop a practical approach which you can customize for our needs. The definition of sterilization is actually, it's a probability function. It's a process wherein we try to reduce the whatever load of the microbiology load is there to 1 in 1 million. So it's a probability function. So what it means is there's a chance of 1 in a million spore surviving this whole process. That is what it means. So it's not absolute, it's a probability. So we are trying to make it as less probable as possible to get a surviving spore. So if I ask you, do you know how to sterilize? Well, most of us would have read this in our microbiology during our undergraduation, that you have to do the sterilization at 121 degrees at so much pressure for so much time. Well, is it as simple as this? Does it hold good for a wrapped cycle or an unwrapped cycle? How did they recommend this value? And does it hold good for instruments with lumens or long phaco tubings? And this is recommended for which type of autoclave? So there are so many questions that are there, not just the time and the pressure and the temperature. So our approach to sterilization has been like fill it, shut it, and forget it, which we should not do. There are various factors that affect sterilization. That is the amount of the organic material, the organisms, the type of microorganisms, the presence of biofilms, and more importantly, the air removal methods and whether we are doing a wrapped or an unwrapped cycle. And how to achieve effective sterilization? We have to implement a consistent system for lowering the bioburden before starting the sterilization itself. Properly preparing the items for sterilization is as important as the sterilization process itself. And once we are doing a sterilization, we should select appropriate parameters. And establishing and implementing these controls to maintain sterility of the sterilized instrument till they are used. This is how we can achieve an effective sterilization. Now, let me make it simple. Let me make the sterilization process as a cooking. Now, if I tell you just cook, it will be childish. You can clean without sterilization, but you can never sterilize without cleaning. Sterilization is a multi-step process, and proper cleaning is the first step of that process. By cleaning, we try to remove all kinds of soil or dirt and whatever the lubricating agents, if at all, we are used on the surfaces on the instruments. This is accomplished by water or water with detergents. The sterilization is important. The cleaning is very important because the sterilization is dependent on the direct contact of the sterilant on the surface of the items to be sterilized. So if you don't clean it properly, then these items will just get baked during the sterilization process. Now, coming to this question, what liquid would you use for your phaco handpiece? The answer is you have to use deionized water or distilled water. Which syringe to use? We have to use a 50 ml syringe. Why so? Because we have to flush with minimum of 120 ml of deionized water or distilled water through each of these ports. And after that, we have to flush again with 60 ml of air. So after the surgery, the cleaning should start immediately on the OT table itself to flush off the tubings so that the drying of the blood, soil, or debris is minimized. You should remember that you should never soak the instruments in saline or sodium hypochlorite solution because the chloride ions are highly corrosive. And don't use hot water because it causes coagulation and prevents removal of protein substances. The various cleaning methods include the friction and the fluidics, or you can use the mechanical and automated cleaners and also ultrasonic cleaners. The cleaning solutions and the water to be used is either deionized water or sterile water would be better for the last wash. And also it's important to understand that the rinsing is the most crucial step of the process because whatever the cleaning liquids that you are, if at all you are used, have to be washed off before you use it. So you should make sure that you rinse properly. There are various methods, but this method has been propagated saying that 3-sink method is better. That is, you wash the instruments with in 3 sinks as is shown in the photograph here. The main thing is not to dip it in a bowl. That's the main message I would like to give, rather than use running water to wash off the whatever materials that are there. So after you're cleaned, then you need to package them. So use the correct packaging material that is required for the autoclave that you're choosing. Then not only the packing, you also have to use the correct sealing machine also, because if you are using a class B autoclave, there's a lot of pressure being generated. I'll show you in the videographs subsequently. So why it is important to have a correct sealing machine also. Then loading the sterilizer. The sterilizer should never be overloaded. You should never overload your sterilizer. You should have spaces in between so that the steam can go through it. Then this is one of the ways where you can load the sterilizer, pack them, and neatly you can arrange them in such kind of trays so that the steam penetration will be equivalent and it can penetrate from all directions or through the, it means the surface area for contact of steam is more. And it's again important to understand that we should load the critical items. Suppose you want to use your phaco handpiece, this should be loaded at the top of your autoclave. because the bottom of your autoclave is the most likely place where the sterilization can fail, while the top of the autoclave is the place where the steam starts from. So you should load your items, the most critical item, at the top of your autoclave. Then coming to the lumen items should be flushed with distilled water immediately before the sterilization, so that some amount of moisture is left inside the lumens. So this will heat up and will sterilize the lumens from inside also. That's what has been suggested. Coming to the water quality, this is what has been suggested. You have to use distilled or mineral-free water to be used during the autoclave, and these are the various parameters that are there. And pH value, it is slightly set 5 to 7. Acidic is been recommended in this document. Then choosing the autoclave, as I was just discussing. So the correct questions to answer when you're choosing your autoclave was, what type of items are you sterilizing? Are you sterilizing hollow, porous, or cannulated items? If your answer is yes, then you'll need a Class B autoclave. So if you see here, the steam sterilization can be of Class N, Class S, or Class B type. And the Class N type is not suitable for doing sterilization of wrapped instruments. And if you see autoclaves, the large autoclaves, you can have a vertical autoclave or a horizontal autoclave. Technically, both are same. The only difference is between the ease of loading or unloading this, the whatever equipment that or instruments that you're putting inside. But technically, both are same here. But if you see in this photograph, there are two horizontal autoclaves. These are slightly different. If you can see here that it has got a pump outside here. So this is actually the vacuum pump. So in using this vacuum pump, the air inside the sterilizer is removed, turning this horizontal autoclave into a Class B autoclave. So you have these advanced kind of sterilizers also, wherein they have more efficient air removal prior to sterilization, and they can also achieve faster drying times. Now, again, there's a lot of confusion between a flash autoclave, whether it is a Class B autoclave or a non-Class B autoclave. So what you should understand is, autoclave can be a smaller autoclave. It can be of any type. It all depends whether you are having a vacuum or not. So if you have a vacuum, that is a fractioned vacuum, then it becomes a Class B autoclave. If it doesn't have, then it becomes a S-class autoclave. So smaller autoclaves can be of S-class or Class B also. It is basically the space that is required to keep these autoclaves that will decide on which type of flash autoclave or a tabletop autoclave that you would like to have. So the flash autoclave doesn't mean it is not a B class. We should see whether this autoclave has a vacuum removal or not. If it has a vacuum removal, then it is a Class B autoclave. So the Class N autoclave is older technology wherein the air removal was poor. And if you see, the air removal improves when you go to the Class B. There are various mechanisms which are used to remove the air. And when you are doing a pulsed vacuum or a fractionated vacuum, that's when the air removal is said to be good. So the Class B comes as an autoclave that can be of very useful when it comes to ophthalmology, because we use lumened instruments. Now coming to this question, which is the steam here? Well, if you think that this is the steam, well, that is not the correct answer. This is the steam here. Actually, the steam is actually an invisible gas. What we are actually seeing are tiny droplets of water which form when this invisible steam comes in contact with the colder air. So what you are seeing actually like a smoke is actually condensation, wherein the steam is getting converted when it hits a colder surface. So why it is important to understand this is because the steam that is used in sterilization actually carries the heat. So it is the heat carrying vehicle, and when it comes in contact with a colder object, that is your load or the instrument, it condenses. And when it condenses, it transfers its heat to the instrument. And it is this heat that is which is responsible for killing the bacteria on the load. So steam is a vehicle to transfer the heat, and it's the heat which does the job. So what does air do to this heat carrying steam vehicle? So it acts as a speed breaker. So it doesn't allow the steam to contact the load. So in a gravity displacement, the air is forced out of the chamber through as the steam is getting injected, while when a class B autoclave, it is actively removed via a pump. That's the difference. Now, if you look at this video here,
what we see here is an example for the negative impact of remaining air during steam sterilization.
So you have a class N and a class B autoclave here.
Gravity or flash sterilization. On the left side, a ball, an aluminum ball of a specific mass, which is equivalent to 10 kilograms stainless steel, in a gravity chamber when no air was removed. On the right side, in a prevac chamber where air was removed. And the difference is clear. The left side, we see clouds, a mixture between steam and air, and that hinders condensation to take place. On the right side, we see condensation taking place, and with the effect that this ball, because of the thermal energy which is transferred by condensation to the ball, is really heated up to sterilization temperature. The ball on the left.
So what basically is happening is, on the left side, you can see that ball of similar sizes of two balls. The heat is getting transferred in the ball on the right side, and that's why more heat is getting transferred and more water is getting formed at the bottom of the beaker. So in a class B autoclave, because of the removal of the air, the steam penetration will be better. That's what this video demonstrates. So coming to the phases of the sterilization, the first phase would be the stage of air removal that we would see in a class B autoclave. Then is a phase 2, wherein there is increasing pressure and temperature before we reach the holding time of the sterilization temperature. Once you reach the sterilization temperature, you have to maintain at that temperature for some particular time. That is called as the holding time. And once you finish that, then you again involves removal of the steam, and then the drying happens. So these are the phases, and it's important to understand all these phases, because this will, depending on the load, you have to alter some of these phases. So coming to the pulsed vacuum I was showing you. So here you can see the steam being injected. You can see how this wrapped item is expanding, how the packaging is getting expanded when we are injecting the steam into the sterilizer. And this is when the vacuum cycle starts. So you can see whatever instruments that we are packing is undergoing so much of changes inside the sterilizer. And if you don't have a good sealing machine, definitely these packages will give way and their sterility will be compromised when you take it out and store it. Coming back to the sterilization, as I told you, it is similar to cooking. But it's also important to understand what we are cooking inside. Because if I say to cook rice, use a rice cooker for 15 minutes, but inside the rice cooker, if you're also putting a meat, then you need to use a different time and duration. So you cannot use the same time and duration for that. Again, coming to the hollow instruments, you have type A hollow loads. This is what we commonly use in ophthalmic instruments. So what I mean to say is the instruments that are using, like the phaco handpieces and tubings, are similar to the meat. So you need to use the correct parameters to sterilize these instruments. Then depending on the other variables, you have wrapped or unwrapped, whether it's hollow instruments or linen. It's also important to understand when you're using different types of loads within the same load, like different type of instruments, then you have to change accordingly. Suppose you are using a wrapped cycle, then your holding time will increase. So also would be your drying time. As far as you're sterilizing your handpieces, you should understand that 121 degrees is not validated or given by the manufacturer. So this is for the Alcon Ozil handpiece. And when it comes to gas sterilization, this is not recommended at all. If you are using reusable tubings, you go back and see what they have told you in your equipment manual, that they can reuse up to 20 cases only. And these people are given that you can do the sterilization at this temperature, but they are not specified what is the holding time and what is the type of autoclave that you have to use. But however, it's important to understand that whatever we do, we have to validate it ourselves. The validation of the steam sterilization is just like tasting. You have to use physical indicators, chemical indicators, and biological indicators. I think the other talk will be covering this in detail. I'll just go through it. So there are various classes of indicators, and it's important to understand these are not in order of higher, it doesn't mean the type 1 is better than type 6. What it exactly means is these indicators are for a specific purpose that we are using. And we need to keep these indicators for appropriate function. Like a type 1 indicator just indicates that this water load you have put in has passed through the test. That's all, passed through the sterilization step. But it will not give anything extra above that. So there are various categories or types of indicators which you have to use for specific purposes. And you may also have to use the process challenge devices like what you see here, depending on whether you're using a reusable tubing or not. These are the other recently in the market. This is the Ophthal BMS that from GKE, wherein you can use emulating integrator and indicator inside this, which will emulate a phaco handpiece. And the other ways to do this, the indicators that we use are the biological indicators. This is the self-contained indicator along with a PCD, which can be used for monitoring your sterilization processes. So in conclusion, sterilization is a probability function. Every sterilizer is different. And what works for a Dr. A in his particular sterilizer may not work in your sterilizer, even if it belongs to the same class or same manufacturer. So only way we can try to reduce infection is to do everything possible, which means compliance with the best practices, not some of the time, not most of the time, but all of the time. Thank you very much.